Welcome to this explainer. Okay, let's just dive right into it. You know, if you grew up watching Knight Rider, you definitely remember Kit, the ultimate sci-fi dream, right? A car that could drive itself, talk to you, and just perfectly roll up whenever you called it, no matter the weather. Total television fantasy. But the fascinating reality of today's autonomous technology, it's actually starting to catch up to that fiction. So today, we're popping the hood on self-driving tech. We'll explore the artificial minds, the incredible sensors, and the massive societal shifts happening literally right now to make that sci-fi dream our everyday reality.
So here's the ultimate question. When are you finally going to get your own completely self-driving car? To answer that, we really have to separate the marketing hype from the actual realistic timeline of modern mobility. And to do that, we're going to break down exactly how these machines actually see the world, how they think their way through crazy, chaotic traffic, and, well, what happens when things go wrong. It's a wild journey from human control to full artificial intuition.
Now, to map this out, we have to look at how the industry actually measures progress. It's not just a guessing game. There's a strict 6-level scale. Level 0 is just your classic manual car. Level 1 gives you a little bit of help. Think adaptive cruise control, freeing up either your hands or your feet. Then there's Level 2, which is supervised autonomy. This is where systems like Tesla's full self-driving are right now. You can take your hands and feet off, sure, but your eyes absolutely must stay glued to the road. You're the supervisor. But here is where it gets really interesting. The crucial shift happens right here, between Level 2 and Level 3. At Level 3, your eyes are free. You can literally scroll on your phone. Level 4, your brain is free. You can fall asleep, though the car is still restricted to certain areas or weather conditions. And Level 5, that's KIT. No steering wheel, 0 restrictions, go absolutely anywhere. And the massive secret behind this whole scale? It isn't just about the tech. It's about legal liability. At Level 2, if there's a crash, legally, it's on you. But from Level 3 onward, the liability begins to shift entirely onto the manufacturing company. And trust me, that changes the whole game.
All right, Section 1, the battle of ideologies, Tesla versus Waymo.
Because those liability stakes we just talked about are so incredibly high, the biggest players in the industry are taking wildly different approaches to cross that Level 5 finish line. On one side, we've got Waymo, born out of Google. Their approach is strictly rule-based, heavily geofenced, and totally obsessed with absolute safety first. I mean, get this. When a massive power blackout hit San Francisco, breaking the normal rules of the road, Waymo's vehicles literally just stopped in their tracks. They recognized a rule anomaly and basically froze to avoid any risk, safely taking on 0 liability. Then, on the flip side, we have Tesla. Tesla champions an end-to-end AI model. They want a system that works everywhere, globally, right out of the box, making it highly scalable, but it firmly places the liability on the human driver for now.
Think of it kind of like a teenager learning to drive. Waymo's rule-based approach is like meticulously memorizing the entire driving manual. They write near infinite lines of code for every possible edge case. If the object is over 50 centimeters, stop. Under 50, keep going. Tesla, though, they're trying to build actual artificial intuition. They feed vast oceans of global driving data processed by these massive GPU supercomputers straight into an AI. They aren't giving the car a rigid set of rules. They're giving it millions of miles of human experience so it can instinctively figure out what to do when something totally unpredictable happens.
Moving on to Section 2, anatomy of an autonomous vehicle. Let's see how these things actually perceive the world. An artificial brain is pretty much useless if it can't actually sense the world around it. Let's do a quick tour of an autonomous vehicle's anatomy, mapping its hardware straight to our own human senses. First up, cameras. These are the eyes. They see color, they read signs perfectly, but just like human eyes, they struggle terribly at night or in a heavy downpour. Next is the IMU, the inertial measurement unit. Think of this as the car's inner ear. It gives the vehicle a flawless sense of balance, tilt, and acceleration. Then we have radar. This is sort of like electromagnetic vision. It can see through thick fog up to 400 meters away, although it doesn't give you high-resolution detail. And finally, LiDAR, giving the car hyper-accurate 3D precision mapping. Now, LiDAR, which stands for light detection and ranging, actually has a really fascinating history. It shoots out lasers to measure precise distances. And get this, it's a technology originally used on the Apollo 11 mission. Yep, they left mirrors on the moon, shot lasers from Earth, and measured the return time to get the exact distance. That is the insane level of precision we're talking about here. But that precision comes with a steep price tag. Historically, we're talking up to $15,000 or $20,000 per unit. And that perfectly explains our earlier comparison.
Waymo uses a hybrid of all these sensors, including that super expensive LiDAR, because they accept the legal liability and absolutely need absolute safety. Tesla, meanwhile, relies strictly on those cheaper cameras, because LiDAR is just way too expensive to scale globally for everyday consumers.
But hey, the real world is messy, right? Sensors get hit by rain, dust, random electrical noise. So how do these cars actually think through all that chaotic data? They use another brilliant piece of Apollo-era tech called the Kalman filter. Invented back in the 1960s, this mathematical algorithm essentially filters out all the noise from the sensors. It looks at a moving object, say a pedestrian running across the street, and even if a camera blinks out for a microsecond, the Kalman filter mathematically guesses exactly where that person is going to be next. It essentially connects the dots to continuously estimate the optimal position of everything around it.
Okay, but what about when the car completely loses its overall place in the world? We've all had our GPS just instantly vanish the second we drive into a long tunnel. Autonomous cars survive this using something called dead reckoning, by calculating their exact entry speed, the time that's passed, and using that IMU's tilt and direction data, the car can calculate its exact location without a single satellite. It's exactly like walking into your house, having the lights suddenly go out, and mentally counting your steps in the dark to navigate perfectly to the kitchen. Same exact concept.
Even with all those incredible senses, a car still has physical blind spots. A giant delivery truck in front of you can easily hide a pedestrian. To solve this, the industry is moving toward V2X, or vehicle-to-everything technology. This actually allows the car to talk directly to the city itself. Through cellular networks, city CCTVs and smart traffic lights can beam data straight to the car, basically telling it what's around a blind corner. Imagine an ambulance approaching from a mile away. V2X allows that ambulance to seamlessly tell the intersection to turn the light screen, completely clearing out the traffic before it even arrives. It's wild. Which brings us to Section 3, the final hurdles, society versus the machine. So, with all this mind-blowing technology, why aren't these cars parked in our driveways right now? Well, the biggest hurdle isn't actually technological anymore. It's psychological. Society completely tolerates thousands of human driving errors, but we have absolutely zero tolerance for a single machine mistake. Human crashes happen every single day, and we sort of just accept it as a tragic fact of life. But when a machine makes a mistake, it makes international headlines. I mean, General Motors reportedly lost billions of dollars scaling back their Cruise autonomous operations due to the massive public backlash and regulatory scrutiny after just one severe accident. There is intense social resistance. Plus, we still have to figure out the classic analytical trolley problem. If a crash is completely unavoidable, how do you program a machine to decide who to save? These are profound, heavy, legal and ethical questions that society just hasn't fully mapped out yet. Yet, if we can look past the fear for a second and just focus purely on the mathematics, the reality is actually pretty striking. Statistically, human drivers get into an accident roughly every 500,000 miles. But if you look at the data from Waymo, their fully autonomous vehicles experience a crash only once every 1.26 million miles. The math literally indicates that severe accidents are 80 to 90% lower with these machines compared to human drivers. It's a huge difference. We really just have to overcome our own inherent fear of trusting the machine. And, to power all of this safely, the vehicle needs an absolutely massive amount of energy. Generating real-time 3D maps, running complex AI on supercomputers in the trunk, constantly firing off lasers, all of that drains huge amounts of electrical power. This is exactly why you pretty much never see a gas-powered autonomous vehicle. There's this deeply symbiotic relationship here. The massive computing power required by autonomous sensors makes giant electric vehicle batteries the only logical, efficient power source. The evolution of self-driving is permanently, inextricably tied to the evolution of the EV. All right, Section 4, the future of mobility. So let's take all these moving parts, the AI software, the lasers, the societal hurdles, the giant EV batteries, and ground them into a realistic timeline for you. This journey has actually been incredibly long. Believe it or not, it started way back in 1925 when Francis Houdina drove a radio-controlled car right through New York City. Sure, it was remote control, but the seed was planted. Fast forward to today, we actually have level 4 robotaxis operating in specific geofenced cities. Looking ahead to around 2028, industry experts are expecting commercial autonomous shuttles and public transit to become heavily standardized. But what about that personal level 5 go absolutely anywhere kit car we talked about at the very beginning? Well, that requires a leap in hardware and processing so massive that engineers compare it to trying to fly to the moon. Going from level 2 to level 3, that's like building a better airplane. Going to level 5,
That's like redesigning the whole thing into a spaceship. It's a completely different foundational architecture that honestly is still years away.
But when that day finally does come, it's going to fundamentally alter human existence. And I want to leave you with this final crazy thought. What will our cities actually look like when cars literally never need to stop? If shared robotaxis are just constantly circling, dropping people off and immediately picking up the next passenger, the entire need for static parking vanishes. Imagine entirely eliminating concrete parking lots and massive, ugly parking garages from our urban landscapes and replacing them with housing, open spaces, and lush green parks. The ultimate promise of autonomous driving isn't just about a car that drives itself. It's about a completely redesigned, much more human-centric world. Thanks for joining me on this explainer, and hey, keep your eyes on the road ahead.